Hey everyone, and welcome! We're doing something a little different today. We're going to take a snapshot of our universe right now, as it is on September 16th, 2025. We'll look at a celestial meetup you can actually see tonight. We'll explore a close encounter that's going to captivate billions. And we'll check out the amazing new tech that's tackling our biggest challenges in space.
So, here's our flight plan. We're going to start right here at home with the show you can see in the night sky. Then we'll zoom out to some cosmic visitors just passing through. After that, we'll take a hard look at the growing problem in our own crowded backyard. And this is the cool part, the incredible new tech being built to solve it. And finally, we'll wrap it all up and see what it all means for our future out there.
All right, first up, tonight's celestial show. Let's ground ourselves for a minute and just look at what's happening right above our heads. Seriously, let's forget about deep space for a second. Just imagine you're stepping outside tonight, into the cool air. You look up. What can you actually see? Well, as it turns out, there's quite a bit going on. So, if you're lucky enough to be listening from high latitudes, you might be in for a real treat. We've got some leftover fast solar wind hitting us, which means there's a pretty good chance for auroras. Yeah, the geomagnetic activity is calming down, but the Cape Index, which is just a scale for solar storm activity, is peaking at a 4. That means places like Canada, Alaska, and northern Scotland could still get a spectacular light show. So keep your eyes peeled. And for the rest of us, well, you're going to want to look up in the pre-dawn sky. The crescent moon is having this beautiful little celestial meetup with the giant planet Jupiter. And right next to them are the twin stars of the Gemini constellation, Castor and Pollux. They're all going to form this kind of cool, slanted rectangle up there. What a way to start your day, right? Okay, so while some things in the sky are pretty predictable, other things, well, they're just passing through. So let's zoom out from our local night sky and take a look at some really fascinating visitors making their way through our cosmic neighborhood. 2 billion. Just let that number sink in for a second. That's how many people, with their own eyes, will be able to look up and see the asteroid Apophis when it flies by Earth in 2029. And if that number doesn't blow your mind, listen to how Richard Binzel from MIT puts it. He says 4 times more people than saw Neil Armstrong walk on the moon. I mean, wow. This isn't just going to be some astronomical event. It's going to be a shared human experience on a scale we've almost never seen before. And when you dig into the details, this thing is just wild. Apophis, yep, named for the Egyptian god of chaos, is going to pass totally harmlessly by us. But here's the thing. It's going to come closer than our own high-altitude communication satellites. An event like this is incredibly rare. And let me be clear, it poses absolutely zero danger. But what it does offer us is this priceless opportunity, a natural experiment for planetary defense. We get to study, up close, how Earth's gravity messes with an asteroid's path. But Apophis is kind of one of our neighbors. Astronomers are now pretty convinced that interstellar visitors, objects like the Comet 3I Atlas that come from other star systems, are actually the most common big things floating around the Milky Way. Think about that. There's almost always one of them zipping through our solar system, but they're so small, dark, and moving so fast that spotting them is just incredibly difficult. So, from these natural visitors, let's turn to a problem that's entirely of our own making. Let's talk about our crowded backyard and the growing challenge of space junk. Over 14,000. That's how many pieces of space junk we can actually track that are clogging up low Earth orbit right now. And we're talking about everything from dead satellites and old rocket stages, all the way down to tiny nuts and bolts, all of them moving many times faster than a speeding bullet. And all of this junk leads to the risk of something called the Kessler syndrome. And honestly, it's the ultimate nightmare scenario for spaceflight. One collision happens, creating a cloud of shrapnel. That shrapnel then causes more collisions, creating even more debris. It's a chain reaction, a runaway effect that could, in the worst case, make huge parts of orbit totally unusable, effectively trapping us on Earth for generations. Okay, that sounds pretty bleak, I know, but here's the good news. With a problem this big comes some seriously brilliant innovation. So let's look at the next technological leap, the incredible solutions being dreamed up for this new era. Okay, you have to check this out. A researcher in Japan, Kazunori Takahashi, has come up with this super clever, totally contactless way to clean up orbit. Get this. A satellite uses 2 ion thrusters pointing in opposite directions to just hold itself perfectly still. Then, it fires a beam of plasma, ionized gas, at a piece of junk. That gentle constant push acts like a brake. It's just enough to slow the debris down until gravity takes over, and it falls out of orbit and just burns up safely in the atmosphere. No nets, no harpoons, just a gentle push. So cool.
And that's not the only idea out there. The European Space Agency is working on a similar non-contact method. They're testing powerful lasers on the ground to gently nudge debris onto a safer path. It's called laser momentum transfer, and it could one day act like a kind of orbital traffic control system, just pushing things out of the way before they cause a problem.
But what about just getting to space in the first place? This is where things get really, really exciting. There's a company called Venus Aerospace that has pioneered what's called a rotating detonation rocket engine, or RDRE. Now, instead of the steady, continuous burn of a normal rocket, an RDRE works on a continuous series of controlled explosions. There's a detonation wave that just races around a circular channel, constantly pushing. The result? A massive 15% boost in efficiency. And it doesn't even need those super complex cryogenic fuels.
Hey, don't just take my word for it. The former deputy administrator of NASA, Pam Melroy, called this efficiency jump a game changer. And she's right. This isn't just a small improvement. It's a fundamental leap forward in propulsion that could totally redefine how we get to space and what we do when we're there.
So, where does all of this leave us? Well, that brings us to our final section, our future in space. It's really a story about an incredible journey of progress.
Just consider this for a second. In 1949, on this very day, a V-2 rocket carrying a monkey named Albert III exploded just 10 seconds after it launched. It was a tragic early failure. Now, fast forward to 2029. Billions of people will watch as humanity studies an asteroid up close as it safely flies past our planet. The contrast between those two moments, it's just staggering.
Think about it. In a single human lifetime, we've gone from rockets exploding on the launch pad to developing revolutionary new engines. We've gone from our first tiny steps into space to building sophisticated systems for planetary defense. Our relationship with the cosmos is changing, and it's changing faster than ever. It really makes you wonder, doesn't it? What's the next great challenge we're going to solve?